Hello everyone, Namaste. I, C.R. Mohan Kumar, Assistant Professor, Department of E&C, SSIT, SAHE. Today I am giving a brief lecture about what exactly control system is, basic terminologies we will use in the control system, and then we will see what exactly system is, and then the classification of the system, and then we will move on to the control system and the classification of the control system. Okay. In this short video, we'll focus more on only the introduction part, what has to be studied in the future classes. Okay. So this control system, it's the main course for electrical sciences branches like electrical, electronics, telecommunication, biomedical, and as well as instrumentation. Okay. So in this subject what we are lecturing today is very important, as well as in day-to-day life this is more applicable. Okay. So we'll start. Okay. Well, as you see today, wherever we see a system, the involvement of control system in it is more and more. What exactly I mean is, you take any example as a refrigerator, air condition, or you can take any automobile. There the application of control engineering is so much involved. Okay. So this all started in early 1900. Okay. In those years, the civilization started reshaping itself. That means there is an industrial revolution is going on, and then there was so much of war. Every country directly or indirectly involved in world war. So the application of control engineering was very much needed. Okay. I'll give an example. Let's say in war zone we require a system which position the gun towards the enemy, or we require an autopilot in emergency cases, or in any other cases it has to take care in absence or with the help of the pilot. Okay. Similarly, there are n number of applications are there. So the requirement of this technology, what control engineering, was very much needed. Okay. So as I already quoted, in day to day there was so much application of control engineering in day to day appliances. Okay. So there are few I already quoted: automobiles, refrigeration, as well as air conditioning. Okay. So in this today's lecture, what we do is we will study or briefly introduce what exactly system is, and then we will see what exactly the classification, and then control system. Okay. So well, you can see, okay, the system to be controlled is given by many names. Okay. So for the most commonly used are process, plant, or control system itself. Okay. So these are the name which always coined in referring to a system which has to be controlled. Okay. And then see, there are applications where it is required to control of these parameters: temperature, pressure, liquid level, humidity, and etc. There are few I have quoted. So these are the parameters to be controlled or to be measured. Okay. So these are the parameters, and all these parameters follows laws of physics. Okay. So what we do is, in this short lecture series we will study what exactly system is, then classification of the system, and then we will jump onto the control system. Okay. So we, as an engineer, we already know there is a prerequisite of signals and system. Okay. So recalling that, will define a system something like this. It is a collection of physical, biological, or abstract components which act together to achieve a certain objective. As I already quoted as an example of refrigeration, air condition, or an automobile, there are so many physical components involved, and all those physical components acts as a single unit to achieve a single objective. Okay, so you can see here a small block diagram I have written. So let's say this is the system, and for every system we will provide an input, and then for every input we will expect some output. Okay, as well as this we will on and off use some notation, like whenever we represent a system in time domain, let's say input we usually call it as u of t, where t represent it is in the time domain. So the notation t representing the time. Okay, as well as I told, the input either we will write it as u of t, or some of the textbook they refer it as r of t also. Okay, similarly output is y of t, or sometime it is called as c of t. Okay, so these are the common notation we on and off use in system. Okay, so as the definition, it is a collection of physical, biological or abstract components, but we will stick on to only our subject where we are only studying the physical system. Okay, so what we do is, with respect to that, we will classify our system into different types. Okay, so let me show a slide. Okay, so this is the simplest classification of system can be done based on nature of the system. So this is the prerequisite we have already studied in signals and system, where the classification of the system can be done based on the nature of the system. Okay, so the first one very simple, that is linear system and non-linear system. I will explain it to you people. Let's say we have a system where the output varies with input, that is the output changes with respect to input, then such systems are called linear system. Okay, then what is non-linear? Non-linear system where the output does not varies with input, or we can define even though simpler, like the systems which follows superposition theorem are homogeneity, then such systems are called as linear systems. The systems which doesn't follow superposition theorem or homogeneity, then such systems are always quoted as non-linear system. Okay, then we'll come back to the previous slide. Okay, then next type of system we will take is time invariant system and time variant system. So name itself is suggesting, if the output is completely depending on the time, then such systems are called time variant system. If it is doesn't depends on the change of time, then such systems are called time invariant systems. Okay, so these are most commonly used in signals and systems, where the systems which follows or with respect to time it is changing the output, then such system is called as time variant. If it is doesn't depending on the time, then we call it as time invariant systems. Okay, so next category or next type of system is static system and dynamic system. These are the systems we on and off use in digital systems. That is, if the system output depends on only the present inputs, such systems are called as static inputs or static systems. Okay, if a system depends on both present as well as past inputs, then such systems are coined as dynamic systems. Okay, the best example for static system is combinational circuits, where decoder, multiplexer, adders, we can name many. Similarly, for dynamic system we can give an example as sequential circuits, where counters, registers and so on can be coined. Okay, so next type of system is causal system and non-causal system. So these are the interesting thing, where causal and non-causal, the system where the output is depending on whatever the input which is present at that time. Okay. So let's say we have a circuit where we are rigging up a circuit with respect to voltages and resistor. Okay. So at any point of time, if you see what is the changes with respect to Ohm's law following what is the current, then we can easily coin it as voltage and current relationship easily. Okay. Even if you calculate that value now or after half an hour or after 1 hour or after any day, the results or the output remains same. Okay. Let's say we will take an example of we are measuring the mass of the aircraft. Okay. So the mass of the aircraft, if it is in the aerodrome, the mass of the output, that is mass of the aircraft is different. After reaching the destination, if you measure the same, the value will be changed. That means with respect to time, the output is changing. Or one of the craziest example we can quote, that is the students which are preparing for examination which is happening tomorrow. So what they do is they anticipate what will be the paper or what are the question may be coined. So that means depending on the future, they are preparing today. So such systems are called as non-causal systems. Even weather forecast also we can take it as one example. So these are the different examples we can coin it for non-causal systems. Okay. So as I told, so these are the prerequisite we have learned from the signals and system, where the classification of system can be achieved or done based on the nature of the system. Okay. So now we have a fair idea what exactly the system is. Now what we do is we'll jump on to something called control system, which is of our interest. Okay. So I'll put it the next slide. Okay. So the simplest block diagram I have written here. Okay. And then a simple definition we can easily see here. A control system is nothing but a system which regulates itself or regulates the other system. That means self-regulation or the regulation of the other device. Such systems are coined as control system. Okay. So this is the simplest block diagram we can write. You can see from here. Okay. So there is a process, as I told, you can call this as a control system or plant or process. Okay. So to this system we have connected one more system called controller. Okay. So this controller is actually taking the input, that is desired value or reference value, and whatever the controller is giving as an output, the controlled values which acts as an input for this actual process, and then we will measure what is output. Okay. To better understand this, let's say the whole process we are actually regulating a temperature of a room. Okay. So this process is we are actually regulating the temperature of the room. Okay. So what this control is doing is it will take the desired value. That means at what temperature this room has to be maintained, that will be given as the desired value or the reference value, and the controller, depending on that desired value or the reference value, it generates output which in turn becomes the controlled input for the process, and that will control the process, that means room heating, and with respect to that the output will be generated. Okay. So this is the simplest control system we can coin, but the problem is this in practical application, whenever the process is happening, okay, so the process will be always have some disturbances. So the disturbances, as I was explaining with example as room temperature condition of this room. So the people coming in and off, and then the opening of the door, the window, or any other parameters, small changes will affect the whole process itself. Okay. So this control system, if it is this simple, or how in the beginning how we have designed it, with assumption that we have a clear idea of input and the output relationship, then if this disturbances occurs, then the system may generate the output which is not our actual output which is required. Okay. So based on this we can classify our system into major two classification. One is open loop control system, the other one is closed loop control system. Okay. So this classification can be done based on a simple concept called feedback concept. Okay. So I'll put a small diagram like this. Okay, let's say we have a system. Let it be a control system. Okay, so for this we are giving an input. So input in the control system usually referred as excitation. Okay, and we are expecting some output, or we say this is response. Okay, so let's say, see, if there is nothing in between, there is a system input we are providing, output you are measuring, such simple circuits are called as open loop circuits. Okay, so as I told in the previous example, to accommodate the disturbances happening or to correct the process, the effect of disturbances in an effective way, so what we do is we will take the output and give back to the input side. Okay, and this whole concept is called as feedback concept, or we will say feedback systems are nothing but a part of the output is taken back to the input side for future iterations, or to correct the disturbances happening, or to correct the process properly, or to get the output which is of desired value. Okay, so this is the simplest block diagram we can write for the feedback concept. Okay, so depending on the feedback concept, that means taking back our output towards input for the next iteration, we can classify our control system into two major classification. One is open loop control system. The other one is closed loop control system. Okay, so this is basically done based on whether feedback is present or feedback is absent. In the open loop, the feedback will be absent, so that means no feedback will be there, or this type of systems is also called as systems which are prone to errors. That means whenever there is a disturbances, then the values or the output may vary. Okay, so if feedback is present, our systems are called as closed loop systems. Okay, so closed loop systems are better compared to the open loop system, where the occurrence of error is there, or we will say whenever there is a disturbances, then we always go for the closed loop control system. Okay, the idea is very simple. If we have a clear relationship between input and output, how exactly input output is related, then we can easily design a circuit or design a system called open loop system. But if the system is prone to disturbances or any external parameters is affecting the process, then we should always go for closed loop system where the feedback will be there. Okay, so the actual feedback help us to improve the quality of the output in iteration over iteration. Okay, so in coming classes, what we do is we will take the examples of what exactly open loop system and the closed loop system, and then with that examples we will move forward and study the control system in depth. Okay, so thanks for joining. We'll continue this in the next class.